Welcome back to the London Futurists podcast. Ben Goertzel is a cognitive scientist and artificial intelligence researcher. He's CEO and founder of SingularityNET, leader of the OpenCog Foundation, and chair of Humanity Plus. But he's perhaps best known for popularising the term artificial general intelligence, or AGI, a machine with all the cognitive abilities of an adult human. He thinks that the way to create this machine is to start with a baby-like AI and raise it as we raise children. We could do this either in VR or in robot form, and hence he works with the robot builder David Hanson to create robots like Sophia and Grace. Ben is a unique and engaging speaker and gives frequent keynotes around the world. I think it's fair to describe both his appearance and his views as countercultural. For instance, he argues that AGI should definitely not be developed and owned by multinational companies. Ben, welcome to the London Futurist podcast.
Well, thank you. It's always a pleasure to be talking to both you and David.
Thanks for joining us, Ben.
Certainly a lot to talk about. A lot going on with AI and various other futuristic technologies these days.
So, Ben, when I saw you at a conference recently, your robot Grace went mute on you. Do you think that in the future, filmmakers and event producers will amend the rule about never working with children and animals to include robots?
After a brief period, there may be a rule to never work with humans. I think it'll go the other way around. Humans don't have the same glitches, but they can get sick. They have a lot of other things that can go wrong.
Fair point.
What happened at that particular event really had nothing to do with the robot. It was purely to do with the PA system of the venue. There was a sound cable plugged into the robot, and some human walking backstage kicked the sound cable out of its socket. So it was in fact a human error rather than a robot mistake. So what we needed was fewer people wandering around backstage.
It proves your point, actually.
I think that will happen. It won't happen precisely by replacing all those people walking around backstage with humanoid robots walking around backstage. It will just happen by reorganizing the way all this transmission of sound signals from devices to other devices goes. If we had decent standards for communication between devices, we should just be beaming the sound through Wi-Fi or something from the robot into the speakers. The fact that we have to use cables is because things are badly configured and set up. I think this illustrates the point about the future unfolding unevenly, which many people have made. To a certain extent, it is true. The future is already here. It's just not evenly distributed. It's not the whole story. We don't have human-level AGI yet. But there's so many technologies that already do work and are very incompletely rolled out.
So the future's already here. It's just not wired together properly.
It's partly true, and we can see that in AGI as well. You have these things like ChatGPT that are good at spewing out sort of plausible-sounding pastiches of what they've read. We also have logical reasoning engines that are pretty powerful at comparing statements to truth and comparing statements to each other. They're not yet connected together. Not to say that there's no fundamental invention left. There's infinite amounts. But on the other hand, there's also a lot of mileage to be gotten by plugging different things together. And I'm doing both of these.
So you raise AGI, and as I said in the intro, you're often credited with coining or perhaps minting the term artificial general intelligence, or AGI. What exactly do you mean by that term?
Yeah, I introduced the term AGI in 2004-05 timeframe, first on some online lists, then in a book titled Artificial General Intelligence, which is a multi-author edited volume. Much like a term like life or beauty, let's say, there's a clear conceptual meaning. One can formalize it and specify it in various ways. And there doesn't have to be one absolute crisp formalization, and it's also okay if it's fuzzy. Like the fact that a virus has some properties of life and some of non-life doesn't make the concept of life meaningless and pointless, right? It just means that it's a fuzzy concept with multiple different dimensions and aspects to it. Conceptually, what general intelligence means is an intelligent system that can learn and make leaps that are significantly beyond its training data and its programming, and can make a jump beyond what it has been taught or supplied with to something that's qualitatively different. Of course, this is fuzzy, and humans are not infinitely good at that either. I mean, we can be very stupid on many occasions, and of course, we're specialized, for example, to four-dimensional space-time. If we were projecting into a universe with 176.3 dimensions, our brains are not going to generalize to moving around in that space very well, unless we plug some chips into our head or something. So we're not infinitely general intelligences. There's a math theory of infinitely general intelligences developed by Marcus Hutter as the leading light there. I mean, I've contributed there, others have. But one of the things that highlights is how far humans are from being infinitely general intelligences. The notion of an infinitely powerful AGI is one that's really good at achieving any computable reward function in any computable environment. Any AGI system we build in the next decade or so, even if it's 10 times human intelligence, isn't going to be, right? The name of the game for now is try to create systems that have at least roughly the same level of generalization capability as humans, and then have that system take it from there, reason and think about how to improve and revise itself. That system may come up with a better concept than AGI to guide its future evolution, which is great.
I was interested when you started defining it, you didn't use humans as a yardstick. The way I use the term is AGI has all the cognitive abilities of an adult human, and then superintelligence is everything beyond that.
I'm a mathematician. To me, that's like defining a big number as a number bigger than 17 or something. I mean, it's arbitrary.
But if you happen to be 17, it's an important number.
That's how little kids think, right? I mean, my 5-year-old son thinks anyone older than 5 is kind of a big kid, and anyone younger is kind of a baby. And to me, that way of thinking is a little naive. He argued with his 2-year-old sister on that. She's like, no, you're still a little kid. You're only 5. That is how we're going to think about it. But if you're trying to do science, I don't think taking human level of general intelligence as something fundamental makes sense. Just like if you're trying to build vehicles for going on the Earth's surface, fixating on exactly how fast people can run is neither here nor there, because it's not like humans represent some natural threshold in the use of physics to move, nor do they represent some natural threshold in the use of physics to think.
For sure. But there's 8 billion of us, and when we're talking to each other, the level we're at is pretty important to us. If we were talking to aliens, it would be very anthropocentric, but we're not.
For economics, it's very important, because human level general intelligence is around the level you need to get to obsolete human jobs.
Yeah.
That's important. It's important for the development of the AI. Like if it's a lot smarter than people, then people with bad attitudes probably can't squash its ongoing development. Within certain assumptions about AGI architecture, it's also important for how well we can design and debug and manage the system. If you have an AGI system that's not only roughly human level, but roughly human-like, we have at least some prayer of understanding what's going on inside it. If you have a system that's way, way smarter than people, then our chance of understanding what's going on inside it is far less. We could have a system much stupider than people that we also can't understand just because it's so very, very different than we are. There's a lot of reasons to build systems that have roughly human-level intelligence and human-like cognitive architectures. It's easier to think about what their ethics will be. It's easier to slot them into roles in the human world. I guess when thinking fundamentally about how to design AGI systems, how to make machine thinking work, I haven't taken that approach at all, and I've more been looking at what are fundamental principles of learning, reasoning, perception, and so forth, and the particularities of human cognition haven't played into it too much.
We'll be right back after a quick break.
The People in Performance podcast offers insights into the strategic competencies, behaviors, and results needed to increase the performance of employees and leaders. The show looks at all areas of the world of work, including attraction and recruitment, onboarding, training, and succession planning. Tune in to get a better handle on the stages of workforce planning you need to master in order to guarantee long-term success in a rapidly changing world of work. New episodes drop each week. Check out the latest People and Performance episodes on your podcast platform of choice. Follow us on socials and read the latest articles at pppod.com.
So let's ask about how you imagine AGI can be built. Earlier you said we need to plug things together better. There needs to be standards that will allow systems to interact. Is that the key thing about achieving AGI, enabling flow of intelligence?
I don't think there's any one key thing for creating general intelligence. This is a point that's often made in the biology context by Michael Rose, who I'm working with on a project called Rejuve, where we're analyzing the DNA of long-lived flies to discover secrets of animal longevity. He's just like, in biological networks, like the ones that make you live a long time, there is no one protagonist and antagonist. There's no hero's journey. There's no, one molecule that will save everything. Instead, you have a complex network with many factors contributing in a complex way. And people always want there to be one key thing because it's a simple story, and our brains are sort of wired to think in terms of these simple stories. And in a certain sense, AGI is like that. There's really quite a number of factors that are all coming together, and we'd like to think there's one big thing, and in hindsight it might not look like that. But having said that, people still need one simple story, so I'll give one. What I'm trying to do with the OpenCog Hyperon project, which is the crux of my current attempt to make AGI, though there's many other important pieces, you could view it as neural symbolic evolutionary. We're using large-scale neural nets for their power at pattern recognition and pattern synthesis, which is very well known in this year of generative AI. We're using symbolic logic engines for their ability to reason rigorously and do inductive, abductive, deductive reasoning based on experiential data and based on knowledge that came from language or from data sets. And this ability to reason rigorously is egregiously not there in ChatGPT and other such systems. You could potentially get it from neural systems. I'm looking at using actual explicit logic engines for that, which I think are better at it than neural systems are going to be with reasonable amounts of resources. Evolutionary learning refers to algorithms that simulate evolution by natural selection inside the computer, genetic algorithms being the simplest form of these. These are powerful engines for creativity, just like evolution in the natural world is. If you look at it that way, we're integrating together neural pattern recognition and synthesis with rigorous symbolic reasoning with evolutionary creativity, but you can't just glue these together in a sort of awkward way. So we have a system that operates on a large distributed and decentralized knowledge graph, or more properly, knowledge metagraph. The neural, inferential, and evolutionary methods are implemented within the same graph, and they act by progressively transforming the same graph in a way to make it respond to its experience. That's a much simpler story than the reality, but it sort of positions my approach relative to the rest of the AI landscape out there. There's been a lot of deployment of advanced math in terms of figuring out how to make logic, neural stuff, and evolutionary stuff really work together in a foundational way in terms of rewrite rules on metagraphs.
My impression is that people have been talking about the need to reconcile or combine deep learning and good old-fashioned AI, symbolic AI, for quite a while. My impression has been that most efforts to do it are kind of sequential. You have a neural network do some stuff, and then good old-fashioned has a look at it and alters the result, and then perhaps it goes around the loop again a few times. You're talking about doing the two processes at the same time on one knowledge graph. Is that an unusual approach, or is that what a lot of people are doing?
It is unusual. I've been experimenting with this sort of approach since the late 90s, and it hasn't caught on, partly because it's harder, because it's easier to optimize a system for efficiency if it's doing only one thing. If you're building a system that tries to carry out neural net stuff, logical reasoning, and evolutionary stuff on the same knowledge fabric, it's hard to make it efficient. This is really why we're rebuilding the OpenCog platform that's been around since 2008 into a new version called the OpenCog Hyperon. This is mostly for scalability. I was teaching neural nets in the 90s in the university and playing with them in the 80s. The difference between the neural nets we had then and the ones we have now There are architectural variations which are not trivial, but yet not humongous either. The biggest difference is just the libraries for training stuff on huge amounts of data on multi-GPU farms efficiently. I think we need a similar leap forward in low-level software and its use of commodity hardware. We need that for these broader sorts of AI algorithms. So I'm doing a couple things, 3 things along those lines. We're rewriting OpenCog for scalability based on everything we've learned since playing with the first version. We've just started a partnership with a guy named Greg Meredith, who has a company called Firefly.io. He had built a language called Rolang based on a formalism called the row calculus, which is a very sophisticated way of boiling down complex compute processes for efficient execution in a concurrent processing framework. So we're integrating a bunch of Rolang stuff under the hood of OpenCog to allow it to really efficiently use multi-GPU servers in large numbers. It's a paradigm much more sophisticated than the MapReduce framework, which underlies the concurrent processing in what most big tech companies are doing with neural nets and otherwise. And then I'm working with my friend Rachel St. Clair, who has a company called Simuli based out of Florida. We've co-designed an AGI board, basically. So I've designed a chip specifically for metagraph pattern matching. She's designed a chip for hypervector operations, manipulating very large sparse vectors. And so AGI board has my pattern matching chip, her hypervector chip, a deep learning chip, and a CPU tightly wired together on one board, and we're prototyping with that now. We're looking at a bunch of ways to scale this up and make it work. Because really, the main reason this sort of approach hasn't been pursued so much is the math is complicated and achieving scalability is hard. It's sort of like the same reason that functional programming took a while to pick up steam. Everyone could see in some ways functional programming is better than programming in imperative languages. It's just took a lot of math to make functional programming work well, and functional programming languages used to be really slow. Now both of those have been largely overcome, but it just takes time.
Ben, the first time I think I saw you speak, you gave a talk called "We Can Reach AGI Within 10 Years If We Really, Really Try." And that was nearly 20 years ago.
I think it was the singularity in 10 years if we really, really try, actually.
Yes, that's right.
10 years to the singularity if we really, really try. Well, I've been really trying. Maybe you guys have. Unfortunately, the we in that talk and article's title referred to the powers that be, meaning the segment of humanity that controls the majority of resources. And I would say humanity as a whole has not been really, really trying. We've been doing a lot of other stuff with our resources instead. As one example, Obama, who's one of my favorite presidents in recent U.S. history, when some Wall Street companies crashed the U.S. economy, he injected $4 trillion or so into the U.S. economy, largely giving it to banks and insurance companies in various forms. Now, what if we'd spent that $4 trillion on pushing AGI forward, or AGI and longevity forward? We've seen the world economy can fabricate these amounts of money when it feels like it. But we have not opted to fabricate those amount of money and put them in an intelligent way toward developing thinking machines or ending death or making molecular assemblers work. That's really what I meant by really, really try in that context. World War II is an example in U.S. history when the country really, really tried at something and progressed quite rapidly. Yeah, we're not viewing death or AGI on that level of criticality as a society.
Yeah, that's certainly true. One of the people we interviewed recently estimated that it would probably take around $100 billion to pretty much address the problem of death, or aging rather, to pretty much solve aging. I think that is 1/6 of what America has spent defending Ukraine or helping Ukraine defend itself, and a tiny percentage actually of the annual American defense budget. So you're right. A lot of these things are within feasible expenditure bounds. So let's talk about the sort of practical implications. I'm conscious that some of our listeners are probably going to struggle to understand some of the things you're saying because they're quite technical. But if we think about the implications in real life, Sam Altman went to Congress recently and spoke to the men and women who are supposed to pass laws in America and said that if you talk about the upsides of what AGI could do for us, you sound like a crazy person. So let's prove him wrong. So how would you describe the upsides of having an AGI or a superintelligence on the planet with us?
I have very little desire not to sound like a crazy person. And in fact, I'm able to sound like a crazy person talking about taking out the garbage in the morning. If the goal is to make things sound sane, down to earth, and boring, you should probably interview somebody else. To answer the question more directly, I do think that ultimately the benefits of AGI will challenge our concept of what is a benefit. If things go well, if we create AGIs with vastly greater than human intelligence, and these AGIs are well disposed toward humans, pretty much any sort of positive outcome that we want within the scale of human life becomes feasible, and we're then faced with a whole different set of challenges of what do we want and what are our values, which is something we have to think about now, but we're narrowly constrained by practicalities. If you have a superhuman AGI that figures out how to make a Drexlerian nanoassembler, you can 3D print any physical object made of molecules or particles at the human scale using reasonable amounts of energy.
Like the Star Trek replicator?
Yeah, with not just a replicator, because you need design. You want to explain what you want in natural language and just have it built where the AI fills in the gaps in your description. Also, virtual worlds that really work. So, I mean, if you want to have a harem of 1,000 scantily clad chimpanzees, whatever it is you want, there's no ethics to worry about because these are non-sentient virtual creatures in your simulated world. So, I mean, I think you'll have almost infinite capability for human self-indulgence and for people to have whatever they want in life. You'll also have the ability for humans to fuse with the AGI mind in a certain way and go far beyond their human existence, even in a way that destroys their human self, but feels like opening themselves up to a vastly greater intelligence and being. And so it does sound crazy. I disagree with Sam on a lot of things, but I think he's right on that, which is not surprising because it's a really, really simple point if you think about this stuff at all. I think some people will choose to maintain a roughly traditional human-like existence, just get rid of headaches and stomach aches and profound mental illness and just realize what it is to be human in a thorough way without some of these irritating impediments. And that's a meaningful and beautiful thing to do. Some people will choose to fuse with the superhuman God mind as aggressively as possible, which is also a meaningful and beautiful thing to do. And there's going to be a lot of intermediate conditions that we probably can't figure out exactly what they are right now. And we don't necessarily have to choose one or the other. You can make 10 copies of yourself and let one of them fuse with the superhuman AI God mind, one of them be a regular human without stomach aches and the headaches and the need to work for a living, and let the other one get like angel's wings and the ability to breathe sunlight and fly around in space. The issue is not that, and I think Sam Altman understands this much also. The issue is not whether superhuman AGI can create what appears like a paradise within the scale of human life. The question is, what's the transition phase to get there?
Absolutely.
And I think some folks like Nick Bostrom and Eliezer Yudkowsky, Stephen Hawking, have put forth the idea that AGIs that don't give a shit about people are the most likely outcome. And like if we don't do something really special, probably AGIs are going to want to turn all our atoms into extra hard drive space for themselves or something. I think that's completely unwarranted and idiotic. There's no reason to think that AGIs that don't care about us are the most likely outcome. We're not plucking random minds out of...
I think that's a little unfair to Bostrom and Hawking. It's clearly what Eliezer thinks.
I think they're more than a little unfair to humanity, and I think they're causing an extremely bad impact on the human species with this nonsense that they're spewing.
But their position is agnostic, isn't it? Aren't they saying we don't know whether AGI will be good for us or bad for us?
Well, if you read the book Superintelligence by Nick Bostrom, if you can get through it.
Which we all have, yeah.
What he does there is very clever because he's a university don, and he's like the captain of the high school debate club. I love Nick. I've worked with him on projects. He's a great guy. He's a deep thinker. But what he does there is he systematically says we don't know what's going to happen with superhuman AGI, but every sentence he phrases breathes the idea that it's probably going to kill us. You finish that book and you're so clear that he thinks it's probably going to kill everyone unless we do something really special.
I came away from it with an entirely different opinion.
All right.
I thought he was absolutely agnostic. I thought he was saying it could very well kill us, but then again, it could be wonderful. And he has that wonderful essay.
I would say that that's probably because you are a geek who pays more attention to the actual literal logical meaning than to the emotional nuances of the phrasing, but most people don't read it like.
So how do you compare your views to Sam Altman, then, the CEO of OpenAI?
I don't know his views as well. He didn't write a book like Eliezer Yudkowsky or Nick Bostrom did.
But he seems to be quite open to creating AGI as soon as possible.
Nick and Ellie have thought really, really deeply about the philosophical and conceptual aspects, as have I. And I think Nick and Ellie came to the wrong conclusion in some ways, in that they correctly concluded we can't really know whether AGI is going to be good or bad for humanity. But they also have concluded intuitively that unless we do something really special, the most likely outcome is that it comes out bad for humanity, which is why in Superintelligence, Bostrom proposes that AGI be put under the aegis of the UN, where a very small number of people are allowed to work on AGI and others are forbidden from it. Yudkowsky, this is really why he founded the Singularity Institute for AI that became MIRI later. But they've thought very deeply to come to that conclusion. I think Sam Altman is a practical guy. He's a tech company guy. He's neither a philosopher nor an AI researcher. He wants to just do it, like the advertisement says. I mean, he wants to throw a lot of resources at taking the best ideas to come out of the AI sphere generally, throw a lot of resources at it, and try to make a thinking machine before anyone else gets there. Very Silicon Valley attitude.
And how does that approach differ from yours? Because you are also trying to attract bright people to work together.
I think there are two big differences. I mean, of course, there are more than two big differences between us as human beings and in our intellectual approaches. But I think there are two big differences in terms of our specific approaches to AGI. One is he has more faith in big tech companies as a venue for hosting the AGI breakthrough than I do. He switched OpenAI from being open to being closed, but didn't change the name to Closed AI. And he switched it from being a more nonprofit benefit-oriented thing to being a for-profit company, which is now really, really closely allied with Microsoft. My feeling is we'll be better off if the first AGIs are not owned or controlled by any large corporation or any individual government, but we'll be better off if they're more like Linux or the internet than they are like Windows or the mobile phone ecosystem. This leads into my work with SingularityNET and Hypercycle, trying to make a decentralized, democratically controlled infrastructure for AGI, which has its own difficulties associated with it and complexities. The other big difference is he's, for now at least, working on neural net systems that really have a very limited amount of self-understanding and understanding of the other person that they're talking to, and understanding of their positioning in the world. I don't think he's doing this because he specifically doesn't want systems that have real understanding of themselves and of their positioning of the world and of their relationship with other people. I think he's doing it because it's the most expedient thing to do given the technologies that others had developed that his team could grab and throw resources at, like transformer neural nets, most notably, that came out of Google Brain and Mountain View. I think what you really want, though, are systems that have self-reflective capability to understand themselves and what motivates them, and that have an orientation to really understand the other agents that they're interacting with, so they can enter into a sort of I-thou relationship with the other agents that they're interacting with. and really understand the people they're interacting in, what their needs and feelings are, rather than just bullshitting about it. I think he's just after maximum impact, maximum intelligence in some sense as quickly as possible, and isn't worrying too much about what sort of entities in the world are getting him there, and isn't worrying too much about the relationship between the minds he's building and the human world that it's interacting with. Also, I don't think there's too much deep thinking there about once you get something at human level intelligence, what's the next evolutionary steps for that?
Can I simplify that? Can I say there's some architectural differences between the approaches? One is based more on deep networks and everything can be done from there, whereas you are taking a different approach. But there's also a difference in faith. It sounds like you characterize it as Sam Altman has broad faith in capitalism and big tech, which you don't have. You, on the other hand, have broad faith in humanity and all our foibles and wonders, which probably Eliezer and Nick Bostrom don't have.
I don't know Altman, and it's probably stupid to guess because he's a nuanced human being like all of us, and he may not have publicly stated his thoughts. But from what OpenAI is doing, it would appear they have a strong faith in reward maximization as a paradigm for intelligence, which underlies all the batch of neural nets they're creating and that Google Brain created, underlies reinforcement learning systems. I'm far more oriented toward what I call an open-ended intelligence view than a reward maximization view. Now, Eliezer and Nick have sort of assumed that any AGI is going to work by reward maximization, and then they have derived a bunch of scary conclusions from that, like the AGI will just hack its reward function for its own self-entertainment, and the hell with any reward function that humans started out with them. I think they're kind of right about what would happen if you took an AGI based on reward maximization and amped up its general intelligence. I don't think the systems have to be based fundamentally on reward maximization. My read from what OpenAI is doing and from Sam's public statements, which could be a simplification of his view, is that he really believes humans are kind of like reward maximizers, and the building an AGI that's pretty much a reward maximizer is the way to go. And this is effective altruism. This is a very common way of thinking in modern Silicon Valley. It's a way of thinking that quite gets on my nerves, but this becomes a fairly deep philosophy topic. But it's also a practical topic, because it's, are you breeding AGIs that are trying to maximize some reward function, or are you creating AGIs that work in some different way? If you look at my friend Weaver's PhD thesis, Open-Ended Intelligence, he's trying to architect a totally different sort of mind than a reward maximizing agent.
Reward maximizing is just another word for having goals. So if you don't like the idea of reward maximizing, what would the driving force behind an AGI be?
Well, having goals is good, but over my life, many goals have popped up in my mind and then have vanished and been replaced by other goals. A human mind is a complex, self-organizing, dynamical system in which goals can emerge, be pursued for a while, and then be modified and replaced by different goals as part of the overall dynamics of the system, as entrained with the dynamics of the world that it's interacting with. It's not that we don't have goals, it's that there's no uber goal or no set of uber goals that is rigorously driving our evolution.
But that sounds very similar to what you described Bostrom and Eliezer talking about, in that the AGI hacks its own reward systems. It makes up new goals on the fly, which is what we all do, and don't see why an AGI wouldn't do that.
Right, but what they describe as a system that, in the pursuit of its current goals, makes up new goals. I think most of what happens in the mind, in the human mind, is not goal-driven. Goal-driven stuff is there, but I think most of what happens is not so rigorously goal-driven. I think if you're developing an AI to serve a company or a country's purposes, you're going to gravitate toward much more rigorously goal-driven systems than something like the human brain is. Microsoft or Google has specific metrics they're trying to maximize. That's how a tech company works. So you'll be naturally driven toward a system that is quite rigorously driven to maximize certain metrics. Evolution is a lot looser than that. I mean, there's survival, there's a goal to reproduce, but that's pretty diffuse because the need to reproduce is tied in with the whole self-organizing ecological network of evolution. Human evolution has not driven us in nearly as rigorous a goal-oriented way as you get if you're trying to maximize metrics like clicks on a web page or shareholder value.
I'm not sure that's true. I think it's just probably that our system of goals is more complicated and we're less aware of what it actually is. We're very often not aware of the goals we're really pursuing.
You're incredibly badly wrong. That perspective, if it leads to a human-level AGI, it will be a malevolent human-level AGI that leads to all the nightmares of Boström and Yudkowsky coming true. The good news is it's going to be hard to get to human-level AGI that way compared with a more open-ended system. That's what the fate of humanity depends on, that these bad ideas about how to make AGI will not only be more ethically bad in their likely outcome, but will also be harder than a more open-ended intelligence approach that leads to systems with more ability to self-grow and self-evolve.
So we shouldn't end on a bad idea. What would you want to finish with, a thought that our listeners should cogitate on?
Our listeners should cogitate on the open-endedness of human, individual, and collective intelligence, and the degree to which human, individual, and collective intelligence is sort of tied to our drive to not only individuate and maintain our boundaries, but to self-transcend and grow into something new that our previous self couldn't even understand. How can we translate this wonderful open-endedness of human, individual, and collective intelligence into open-ended intelligence of AGI systems that we build, both individual programs and networks of programs interacting together with their emergent AGI? We can reflect on how the open-endedness of life, be it human, individual, societal, biological, or digital, the open-ended of life is both incredibly scary and worrisome and incredibly exciting and wonderful. To me, that's been the case for evolution on the planet before humans came about. It's the case of human society now, and it will continue to be the case as we approach and go through a singularity.
Well, I think that, plus Ben, you telling me that I'm incredibly badly wrong, is a great way to end it. The conversation where everybody agrees with each other is very boring. Ben, thank you very much indeed for joining us on the London Futurists podcast.
Thanks very much, Ben, and we'll let you go and attend to a new goal now by the sounds of things, not talking to us, but addressing the growth and open-endedness of your family.
Thanks, David.
Thanks, Ben.
Thank you so much.